So here is a very large game, and I'll use it to explain alpha beta pruning. So it's a zero-sum game, and we have two players, Max and Min, and I'll just use Max and Min as their names. So we'll start from the leftmost branch, and we'll walk through the whole game slowly. So at the beginning, the first branch, of course, it cannot be pruned because we don't know any information yet, so we'll keep this. And so is this. I don't know any information about O yet, so I'll keep this. So here, let's figure out what information we get so far about alpha and beta values. So for the values for the max player is called alpha, and the values for mean player is called beta. So here, alpha, we know the alpha will be larger than or equal to 4 because the max player is picking the max between these two, the maximum value between these two branches. And this is 4 already. So if this is smaller than 4, I'll just pick the left one. So I'll get 4. If this is larger, I'll pick the larger one, but well, it will be larger than 4. So alpha is larger than 4 for sure. So here, for the same reason, the beta is the mean player. If the mean player picks left, mean player will get -3. And if this number on the right is less than -3, then mean player will pick this, but then it will be less than -3. However, if this number is larger than -3, then the mean player will simply pick the left branch and get -3. So in any case, the beta value is less than -3. So now we know the alpha and beta at the same time, and alpha is larger than beta. So whenever alpha is larger than or equal to beta, we'll prune the remaining of the game. So here we're going to prune this. To explain this more intuitively, the way to think about this is, so if you look at the max player's decision here, Max can get 4 from picking left already. And Max knows that if Max picks right, then Max can get at most -3. So I don't really care how much worse than -3 I can get. I just care I can get 4 here. So any number less than -3 is worse than 4. So I don't really care how much worse than 4 it is. I'm not going to pick this. So basically, Max knows that he or she will pick the left branch anyways. So I'm not interested in figuring out what happens in the right branch. Okay, so then let's go back here. Mean player knows this is larger than or equal to 4, and on the not really larger than or equal to 4, it's just equal to 4, and compare 4 and 5. Oh, so the problem is well, whether we can prune the g here, and the answer is no. If g is smaller, b will prefer the smaller number, and actually it is smaller, so b will prefer this. So the value for b is -5. So it's actually necessary, so we cannot prune this. And then we go back here to the top. The max player, knowing this value is -5, I know that I can get at least 5. So that's the first main sub-branch. Let's continue with the second main branch. So here, again, the first one cannot be pruned, so I'll keep this. And the second one here, let's figure out. So here is the mean player. I know that I can get less than or equal to, so I know my beta value is less than or equal to 3. So technically, the beta alpha is not larger than beta, so we should not prune anything yet. But to think about it intuitively, if this number is smaller than 3, then I still want to see if it's smaller than 3. If it is, then I'll pick this one. So that cannot be pruned. So if you look from the perspective of the max player, if this number is say 2, then 2 is better than -5. So I'm still interested in whether this is 2 or something like -7. So so the max player is also interested. So both players are interested in this, so this cannot be pruned. And for the same reason, the first branch cannot be pruned. So let's keep it, and let's figure out whether this can be pruned. So here we have an alpha value. This is the max closest decision. So alpha value is larger than or equal to 9 because this is the max player. I can get at least 9 from picking the left. So now if you compare the alpha and the beta value, alpha is larger than beta, so it's a sign that we can probably prune the rest. But let's do it intuitively again. So the max player here will pick, do I get at least 9? So for the mean player here, I know that I can get less than 3 by choosing H, by choosing the left branch. And if I pick the right branch, I'll get at least 9, and I'm minimizing. So comparing 3 and 8 and something that's larger than 9, I don't really care. I just want to guess 3. So I don't really care what value, how large it is. I will just pick the left branch. So that's why I can prune the whole subtree. And then let's continue. This one, there's only one thing, so nothing happens. And, and now we know that beta is equal to 3. So now we also know that alpha is larger than 3. Because for the max player, I'm picking the max between -5 and 3 and 0. So 3 is the largest one. So I know I can get at least 3 from C. So this cannot be pruned. Let's continue here. As I said, the first one cannot be pruned. So we'll just skip this. And what about this? So let's actually figure out the alpha beta value. So this is the max player's decision. I know I get larger than or equal to 3. For the mean player, there's no information yet. I have no idea what beta can be. So I probably need to look at this too. So I'll get 5. So now I know this alpha value is 5. And also I know that the beta value is less than or equal to 5. Because this is the mean player, I get 5 here. So if these things are smaller, I will get a smaller number. If they are larger, then I don't care. And then can we prove this? So again, alpha is smaller than beta, so we cannot do anything yet, theoretically. And intuitively, the max player can get at least 3, and the mean player here, it can be for example, if L is 4, then I'm actually interested in it because I can get at least 3. If I can get 4, it will actually be beneficial to both of us. So no, we cannot prove this without knowing the information. We don't know whether it's 4 or not. It turns out to be 2, but when we did not know the value 2 yet, we cannot prove it. So that's the intuition. And then let's continue to here. Um, can we prune this one? So now we have updated beta to be less than 3. I mean less than 2 because of this 2 here. 2 is less than 5. So the main player here will pick L for sure. I mean compare L and K. I don't know what M is yet, but I will pick either say L and M. Now we see that alpha is larger than beta, so we should be suspicious now that we can prove everything. And turns out yes. So the logic is consider the max player here. So the max player can choose C to get a value of 3. And the max player, if the max player choose E or choose the right action, then I can get at most 2. So comparing to exactly 3 and at most 2, 2 or something even worse than 2, then I don't really care how much worse than 2 it is. I will just pick 3. So that's why the value of the whole game is 3 without knowing these two numbers. Whatever these numbers are, the value is always 3. So that's why these can be proved.